Here is another example, and we made a couple of changes here. So x is now initially -1, and we've also changed our second condition to see if x is less than or equal to -2. So with these changes, take a look at the code and see if you can determine the output. So let's check both of our conditions. So is x greater than or equal to 0? Well, we have -1, so -1 is not greater than or equal to 0. That means that x greater than or equal to 0 is going to be false. So now we need to check if x is less than or equal to -2. Well, -1 is not less than or equal to -2. Therefore, x less than or equal to -2 is false. So we have false or false. So since both are false, the whole thing is false. So now we're going to go into the else portion of our statement. So we're going to take x and subtract it by 2. So we have -1 minus 2. That gives us -3. We store that into x. We convert it to a string, put it into our label, and therefore our output is going to be -3. In this example, we have an if-then else statement, but we also have an else if inside of it. We have x and y declared as integers, but we didn't initialize them. So we're going to assume that we do some stuff with x and possibly y in between here. That's what the dot is. So I'm going to ask you what's the output of this code depending on the value of x. So the first one is if x is 59, what is our output going to display? So let's take a look at 59 and see what happens if we go through our if then else statements. So x is 59. 59 is not greater than 70, so that is false. So we're going to go to the else if part, and 59 is not greater than 60, so that's false. So we're going to set y to -1, so our output is going to be y equals -1. Let's do another one. Let's say x is 48. What would our output be? If we follow the code, 48 is not greater than 70, so that is false. Then we check to see if 48 is greater than 60. That's also false. So we're going to set y to -1, and our output is once again going to be y equals -1. Okay, so what about, let's say x is 79. What would our output be in this case? So here we'll compare 79 with 70, and 79 is greater than 70, so that condition is true. So we're going to go into the then portion and set y to 1. Therefore, our output is going to be y equals 1. Let's do one more. Let's say x is 65. What would our output be? So we first check 65 and 70. Well, 65 is not greater than 70, so that condition is false. So we're going to go into the else if portion. We see that 65 is greater than 60, so that part is true. So we'll go into the then portion of that if statement and set y to 0. Therefore, our output is going to be y equals 0. Here we have a very simple expression. We're given integers x and y initialized to -2 and 5 respectively, and we're checking to see if x is not equal to 15 or y is greater than 10. So take a minute to see if you can evaluate the expression. We first evaluate x not equal to 15, and well, x is -2, which is not 15. Therefore, x not equal to 15 is true. So then we can take a look at y greater than 10. Well, 5 is not greater than 10, therefore y greater than 10 is false. This means we have true or false, so the result is going to be true. Let's complicate things just a little bit. Now we have three variables, x which is -2, y which is 5, and z which is 2. And our expression is x not equal to 15 or y is greater than 10 and z equals 3. So see if you can evaluate this expression. So let's evaluate all three of the conditions first. So we have -2 comparing that with 15. Well, -2 is not 15, so we know that x not equal to 15 is true. We check to see if y is greater than 10. We know that's false because 5 is not greater than 10. And then we can check to see if z equals 3. Well, this is false because 2 is not 3. So how do we evaluate this? Well, if you remember our precedence of the logical operators, we evaluate the and part before the or. So this means we have false and false, so that becomes false. So then that leaves us with true or false, so this whole expression actually ends up being true. Let's do the same thing that we had from before, the same code, except now we're going to put parentheses around the x not equal to 15 or y greater than 10. So see what this does to our expression. So let's evaluate the conditions. These are the same from the last slide. So we already know that x not equal to 15 is true. We know that y greater than 10 is false because 5 is not greater than 10. And we know that z equals 3 is false because z is 2. So because we have the parentheses, we have to evaluate that part first. So we're going to evaluate the or operator instead of the and first. So we have true or false. So that means what's in the parentheses is true. So then we evaluate true and false. Well, that becomes false, so the whole thing is false. We'll take the same code from before, except now we change our third condition. Instead of checking if z equals 3, we're now going to check the not z equals 3. So see if you can figure out what this expression is going to evaluate to. So our first two conditions stay the same. So x not equal to 15 is true because x is negative 2. Y greater than 10 is going to be false because 5 is not greater than 10. So what is the next part going to be, the not z equals 3? Well, we know z equals 3 is false because z is 2 and 2 is not 3. That means that not z equals 3 has to be true. So we got to evaluate the or portion because that's in parentheses. So we have true or false, that's going to be true. And then we have true and true, so therefore the whole thing is going to be true. Let's take a look at a slightly different expression where we're using the or else operator. So given the values of x and y, see if you can determine what this expression is going to evaluate to. So we'll check the first condition, the x less than 15. Since x is 10, we know that x less than 15 is going to be true. And because we're using the or else operator, we don't need to evaluate the second expression, the second condition. So we know that this whole thing is automatically going to be true. Here's an example where we use the and also operator. So we're checking to see if x is less than 10 and also y is greater than 5. So look over this to see if you can figure out what this is going to evaluate to. So let's start with the first expression. The x less than 10 is going to be false because 10 is not less than 10. So that part is false. And since we're using and also, we do not have to worry about the second condition. Since the first part is already false, we can skip the second part and just say that this whole thing is going to be false. We'll do one more example, I promise. So here, x is going to be a Boolean value, initially true, and then y is going to be an integer that's initially 15. So here we want to evaluate not x or y not equal to 5. So I want you to tell me what's going to happen in this expression. Let's start with the not x. We know x is true, therefore not x is going to be false. So what about the y not equals to 5? Since y is 15, 15 is not equal to 5, therefore y not equal to 5 is going to be true. Therefore we have false or true, which is going to evaluate to true.